Assalamualaikum and a very good day to all respected judges and fellow participants. My name is FATIN and today I'll be presenting a part of my research project of which I found that polyphenol-rich ester of hibiscus dairy or Roselle or HPE was able to mitigate diabetes-induced cardiac function and structural deterioration via amelioration of oxidative stress, apoptosis, and inflammation. So first of all, where do we stand with diabetic heart disease globally? With the current trend, the global incidence of diabetes is predicted to reach 642 million adults by 2040, impacting both human health and world economies. Heart failure is increasingly recognized as a significant contributor to morbidity and mortality in diabetic patients. Not only do people with diabetes suffer an increased incidence of heart failure, their prognosis once diagnosed is worse than a comparable non-diabetic patient. By definition, diabetic cardiomyopathy is a cardiac dysfunction observed in patients with diabetes mellitus that occurs in the absence of other cardiovascular diseases such as coronary artery disease, hypertension, valvular, and congenital heart disease. So if you look into the term itself literally, cardiomyopathy means disease of the heart muscle. Therefore, diabetic cardiomyopathy means it is a disease of the heart muscle induced by diabetic conditions. So what is wrong with the heart muscle in diabetic cardiomyopathy? Clinically, two stages of diabetic cardiomyopathy have been identified. An early stage characterized by left ventricular hypertrophy, increased myocardial stiffness, and impaired diastolic function, and a late stage characterized by aggravated cardiac fibrosis and hypertrophy, further impairment in diastolic function, and appearance of systolic dysfunction. Diabetic cardiomyopathy is no doubt a silent killer among diabetic patients. This diabetes-induced cardiac complications evolves with the asymptomatic early stage. When the symptoms of cardiac dysfunction starts to appear, it marks the late stage in which the cardiac structural alterations are mostly irreversible. And without proper treatment and management, diabetic cardiomyopathy could rapidly regress toward heart failure. Managing cardiomyopathy and diabetes mellitus is not only financially burdening, but some effective pharmacological agents could also cause undesirable side effects to the patients. So a new cardiovascular agent with fewer side effects and comparable efficacy derived from natural sources might thus benefit the healthcare professionals in managing diabetic cardiomyopathy. The use of dietary antioxidants for natural products was proven to reduce oxidative stress and slows down progression of diabetic cardiovascular complications as summarized here in this table. Moving on to the extract we are studying. Roselle, or its scientific name Hibiscus subdarifa, is a perennial plant native in Malaysia. Traditionally, it is used to treat high blood pressure, treating sore throat and cough, pain reliever, as well as to treat indigestion. Studies on Roselle Calyx extract showed that it possesses various health benefits such as antifibrotic, antioxidant, anti-inflammatory, anti-apoptotic, and may as well control diabetes and obesity. Polyphenol-rich extract of Roselle Calyx, or HPE, is not a foreign extract in our lab. Actually, we have previously studied on its cardioprotective effects on the early development of diabetes mellitus in rats. So in our past study, we supplemented type 1 diabetic rats with HPE shortly after diabetes mellitus was diagnosed post-induction with streptozotocin. So with the extract given for 8 weeks, HPE was found to protect the diabetic rats against developing cardiac dysfunction with minimal regression in both cardiac structure and function. And this protection is believed to be contributed by blood glucose lowering and anti-hyperlipidemic properties of HPE and its potent antioxidant activities, as we saw a significant reduction in cardiac oxidative stress status in the treated rats. So in light of the potential role of HPE as anti-diabetic and antioxidant agent, and the promising potential of HPE as a cardiac protective agent, HPE may therefore potentially able to limit diabetic cardiomyopathy progression. So in order to prove the hypothesis, we induced broad dolly rats with single injection of streptozotocin to induce type 1 diabetes. Then we let them untreated for 4 weeks to allow the diabetic cardiomyopathy to develop. At the end of the 4th week, we started them on HPE treatment using metformin as the positive control and untreated diabetic rats as the negative control. Treatment commenced for 4 weeks before the rats were sacrificed, and ex vivo cardiac function was performed, and the remaining tissue was used for structural and biochemical analysis. Our findings showed that measurement of the left ventricular function of the untreated diabetic rats revealed a significant reduction in both left ventricular relaxation rate and contractility rate, as well as reduced ventricular pressure, exhibiting both systolic and diastolic dysfunction. This finding is consistent with clinical features of advanced cardiomyopathy exhibited in diabetic patients. Interestingly, we found that treatment with HPE was able to improve both systolic and diastolic functions, with prominent improvement in left ventricular contractility and relaxation function. Analysis of the histology also showed that HPE was able to prevent the development of cardiomyocyte hypertrophy and limit the progression of myocardial fibrosis. As glucose toxicity plays a significant role in the development of diabetic cardiac dysfunction mediated by uncontrolled oxidative stress and damage, interestingly, our findings showed that HPE was able to reduce cardiac oxidative stress markers. Consistently, we found that the expression of inflammatory markers, which are interleukin-6 and interleukin-10 in the plasma, were reduced significantly in HPE-treated diabetic rats compared to the untreated diabetic rats. With the attenuation of oxidative stress and inflammation, as expected, analysis of the apoptotic markers gene, in which we measured the gene expression of BATs and BCL2, showed that the overexpression of BATs and reduced expression of anti-apoptotic BCL2 could be controlled upon treatment with HPE. In conclusion, this study suggests that HPE has a therapeutic potential in limiting cardiac dysfunction by targeting cardiac ROS upregulation and cardiac inflammation and apoptosis, hence attenuating type 1 diabetes-induced diabetic cardiomyopathy. A significant reduction in cardiac oxidative stress and restored activities of antioxidant enzymes, as well as attenuation of cardiac apoptosis and inflammation, might have contributed to HPE ability to control type 1 diabetes mellitus-induced cardiac dysfunction, cardiomyocyte hypertrophy, and fibrosis. At the moment, we are currently investigating the potential pathway that HPE treatment may exercise its cardiac protection effects on, and we are very keen to report this in the nearest future once we concluded on our findings. That marks the end of my presentation, and thank you very much for your valuable time.